Today we're going to learn how to use proportions to solve word problems. The main thing you want to keep in mind when you're working with proportions and word problems is to focus on your units. We always want same units to be across from each other. So here I have boys across from boys, and I have girls across from girls. I could set it up upside down and have girls across from girls and boys across from boys. That would be okay as well. It doesn't matter since the two fractions are equal to each other. You also want to make sure that you have whatever ratio you're working with on top of each other. So in this case, we know that for every 2 boys, there are 3 girls, and we have 100 boys altogether, so we're looking for the total number of girls that we'll have. There are a couple ways to solve this. The first way you can solve this is using equivalent fractions. If you use equivalent fractions, that means you're going to figure out what you'd multiply the top and the bottom of one fraction by, or divide the top and bottom by one fraction, or by one number. So here I'm going to multiply 2 times 50, and that gives me 100. So since I multiply 2 times 50 to get 100, I have to multiply 3 times 50. And that will give me 150, so I know my answer is 150. Now, a lot of our fractions are not going to be that nice and pretty and easy. So that's why it's important to use cross multiplication and know that technique. So if we're using cross products, where we cross multiply, we would multiply 2 times x and 3 times 100. So we get that 2x equals 300, or 3 times 100. Divide both sides by 2, so x is 150. Either way, there's 150 girls for every 100 boys. In our next problem, it says if there are 100 boys, how many children are there? Now, we know up in the previous example that there are 2 boys for every 3 girls. So if there are 2 boys for every 3 girls, that means there's 5 total students. So if we have 100 boys and we want to figure out how many students there are, we can use cross multiplication. We can multiply 2 times x and 5 times 100. We get 2x equals 500. Divide both sides by 2, which is the same as multiplying by the reciprocal. And we get x equals 250 students. So there's 250 total students in this example. Again, notice how I set up my proportion. I set my proportion up by having boys across from boys and students across from students. And then, of course, I had my ratios on top of each other, 2 to 5 and 100 to x. Let's look at some more examples. In this example, it takes 3.5 hours to get to Myrtle Beach. So I'm going to put 3.5 hours. Hours is my unit, which is 250 miles away. So miles is another unit. And 3.5 over 250 is my ratio. At this rate, how long would it take for me to go to Charleston, which is 400 miles away? So they tell us our miles. They tell us 400 miles. So we need to put that across from miles, so it'll be in the denominator based on how we set up our proportion. And we're looking for how long, so that means how many hours. So we'll be solving for hours, which goes across from hours. And since I put hours in the numerator to begin with, I need to continue putting hours in the numerator. Now I just have a proportion to solve. 3.5 times 400 and 250 times x. I'm going to do 250 times x first to get 250x, and 3.5 times 400, which gives me 1400. Now I'm going to divide both sides by 250, or divide, or multiply by the reciprocal, however you want to do it. It's the same thing as divided by 250, and I get x equals 5.6 hours. Again, you can do a check step by putting 5.6 hours in the place of x and cross multiplying to see that the two proportions are equal to each other. Here's another example. In this example, I have 6 dozen cookies for $7.50. So I have dozen over dollars. Those are my 2 units. And my ratio is 6 over 750. Now it tells us that wants us to find out how much 2.5 dozen, so they tell us how many dozen of the same cookies cost. So we're looking for cost, so our X goes beside our dollar. Now, if you'll put your units into your proportion, you'll always know that your proportion is set up correctly and what you're solving for, what unit goes with it. So in this case, we know our answer should be with dollars. We should have the dollar symbol beside our answer. We're going to cross multiply, and when we do, we get 6 times X here, and then 7.5 times 2.5 gives us 18.75. So 6x equals 18.75. We're going to divide those sides by 6, or multiply by 1/6, and x equals $3.13. Now I'm going to show you another example. In a scale drawing of a building, the scale is 2 centimeters to 5 feet. So for each 2 centimeters on our paper, that represents 5 feet in real life. So our units are centimeters to feet. How tall is the building? So we're looking for feet. So X is going to go beside feet. If the drawing shows the height of the building as 4.7 centimeters, so they give us the centimeters. Centimeters across from centimeters, feet across from feet. And we are looking for the height of the building, so the real height, the actual feet. We're going to multiply 2 times X, which gives us 2x, and 5 times 4.7, which gives us 23.5. Then we're going to divide both sides by 2, and that gives us 11.75, and you can look up at what you're solving for to see that feet is the units that we need to have beside our answer. In the next example, my car gets 33 miles per gallon of gas. Now, one thing I want you to understand is that MPG, miles per gallon, is actually a ratio. It means 33 miles for every 1 gallon. So in this case, we have miles as 1 unit, and we have gallon as another unit. So 33 miles for every 1 gallon. If I drive 235 miles, so they are telling us how many miles we're driving, and they're asking us to solve how many gallons of gas have I used. So they're asking us to solve for gallons of gas. We have miles across from miles and gallons across from gallons. We're going to cross multiply. 33 times x is 33x. 1 times 235 is 235. When you divide both sides by 33 to get x by itself, you're going to get 7. X is 7. And since we know we're looking for gallons, it's 7 gallons. For our next example, it takes me 3 1/4 hours to get to Myrtle Beach, which is 200 miles away. If I drive to Emerald Isle, 125 miles away, how much time will I save traveling one way? So we know it takes 3.25 hours to get to Myrtle Beach. So that's hours is our first unit. And our second unit is miles, which is 200 miles away. If I drive to Emerald Isle, which is 125 miles away, so we know how far away it is, how much time will I save? So I have to find out how much time it takes to get there first, and then I can subtract to see how much time I saved. So hours across from hours and miles across from miles. I'm going to cross multiply. 200 times x is 200x. 3.25 times 125 ends up giving us 406.25. Divide those sides by 200, and you get x equals 2 hours. I rounded that. So if it's 2 hours and it takes 3.25 hours to go to Emerald, it takes 3.25 hours to go to Myrtle Beach, and it takes 2 hours to get to Emerald Isle, we can subtract, and the difference is 1.25 hours saved. So Emerald Isle is 1 1/4 hours closer than Myrtle Beach. My recipe to make brownies calls for 1 2/3 cups of walnuts. So I already have 1 2/3 cups of walnuts. So we have 1 2/3 cups of walnuts as our first unit. And that makes 12 brownies. So brownies is our second unit. How many brownies could I make with 15 1/8 cups of walnuts? So here I know cups of walnuts, and I'm looking for brownies. I'm going to have cups of walnuts across from cups of walnuts, brownies across from brownies, and I'm going to cross multiply to solve. So I get 1 2/3 x equals 12 times 15 1/8, which is 181.5. And when I divide, I end up with 108.9 brownies. So we would round that down to 108 brownies.